Assalamu alaikum, dear student. Today I welcome you back with the topic AC through resistance, which is given on page number 193. Students, first of all, what is resistance? Resistance can be defined as the opposition to the flow of current in a conductor. It's called resistance. Resistance is denoted by R. The unit of resistance is ohm after the name of George Simon Ohm, who introduced Ohm's law. Resistance is always there. It may be in one form or the other form. In this topic, we are going to explain what happens to the alternating voltage and alternating current when it is passing through resistance or the circuit element resistor. Consider the diagram. The diagram is like we have a resistor and alternating current source like this. The property of this alternating voltage is that it changes polarity all the time, and consequently the current direction should also be changing across this resistance. What happens to the properties of the alternating voltage and alternating current when it is passing through the resistance? So for that, consider the diagram. Let us suppose this side becomes positive and this negative for some time. So direction of the current will be from left to right. This one, I. Current is denoted by the symbol I, small or capital, both acceptable. Students, do you have an equation in your mind which can be applied here on this diagram? What is that law which governs, which satisfies this relation between R and I? Is there an equation which you remind in your mind which governs this equation? Yes, of course, we have Ohm's law, like V is equal to IR, where V is for voltage, I for the current, R is for resistance. Voltage is alternating here, the current is alternating here, and the resistance, it is not a DC source, it is an AC source. So how the properties of the voltage and current changes when they are given to an AC source. This equation simply applies to DC, but what happens to the properties of V and I when they are applied like in AC circuit? Now, this is Ohm's law equation. Another question for you. Can you remind again what physical quantity is dependent and which one is independent in this equation? So let me tell you. V is independent, I is dependent. V is the source, I is the effect. So this effect depends upon this source. So let us write the instantaneous equation for voltage. As it is AC, so we can write this equation like V naught sine of omega t. This is equation 2. V instantaneous is equal to V naught naught sine of omega into t. As voltage is independent, so we can draw the vector showing the voltage like along x-axis, like this. This vector sign here is called a phasor. We are actually explaining the topic with the help of three things. One, mathematical step, another, phasor diagram, and third one will be the graph explaining the properties of V and I when passing through AC circuit. So, as voltage is independent, so independent vector will always be drawn along x-axis. This is origin, this is x-axis. Phasor for V. You must keep this equation in mind and let us move further. As we have already shown an equation like V instantaneous is equal to V naught sine of omega into t. And a phasor diagram will be like this. V along x-axis, which is independent axis. Now, we are going to derive an equation for alternating current from Ohm's law. So, putting the value of equation like V is equal to I into R. This is Ohm's law. We are going to derive an equation for the current. So, changing or modifying the equation like I is equal to V divided by R. Now, putting the value of V in this equation from this one. So, I is equal to V naught sine of omega t divided by R. We can write V naught divided by R into sine of omega t. I is equal to, now as we know that I is equal to V divided by R, so V naught divided by R should be equal to I naught. So simply taking this term equal to I naught and sine of omega t. This is an equation for the alternating current. And this is equation for alternating voltage. This is equation number like A, and this is B. So what are the characteristics, what are the properties of V and I whenever they are passing through alternating current circuit? What you can conclude from these two equations? The most important thing you have to look for is the phase angle here, omega t into omega t. They are same, their phase angles are same. It means the current is in phase with the voltage as their phase angles are same. So, they are in phase. In phase means the current is moving very much parallel to the voltage. And we can show this in the form of another vector for I. As the phase angle between the two quantities is zero, phase angle is same, so they must be parallel to each other. So this diagram shows that current and voltage are in phase whenever they are passing through a resistive circuit. What is a resistive circuit? Like the circuit in which we have applied a resistance R only. So it means when we apply maximum voltage to the circuit, so maximum current will be flowing through the circuit. When we apply zero voltage to the circuit, so zero current should be flowing through the circuit. And the third parameter which explains this concept is the graph. Let us, for example, we draw the graph for voltage like this over a cycle. So we must be having a graph for the current like this. So this is for V and this is for I. Zero voltage, zero current. Maximum voltage, maximum current. Again zero voltage, zero current. Maximum voltage reversed, maximum current reversed. Again zero voltage, zero current. So this is evident from the equations, phase angles. This is clear from the phasor diagram, and again this is explained here in the form of graph. So this is what we call the characteristic for current and voltage whenever they are passing through AC circuits. One thing more important. What should be the power of the circuit? Power is always written as I into V. The product of the current and voltage is called power. What is power loss? What power is there? So P is equal to IV. Or simply we can write P is equal to IV cos of theta. This is an equation for the power. Modified equation for electrical power can be written like IV cos of theta. What is this theta? This is the phase difference between the two alternating quantities. If their phase angles are same, so it means phase difference is 0. So we can write IV cos of 0. Cos of 0 is equal to 1 all the times. We know this. So power dissipated in the circuit is written like simply IV. Thank you. Have a nice day.